My name is Anita Jana binti Zulkifli. I'm here to solve the question. So the question is find a solution to the partial differential equation. So the question is given is du over dt is equals to k d square u over dx square. So and here we have three boundary conditions, which is u at 0 is equals to fx, u negative lt is equals to ult, and du over dx negative lt is equals to du over dx lt. So first thing, we will rewrite them so that it will be easier for us to see. So we will write them as u negative lt minus ult is equals to 0, and du over dx negative lt minus du over dx lt is equals to 0. So this is, as you know, this is the assumption that we use in several variable method, which is u x t is equals to vx gt, and this is the two ordinary differential equation that we will need to solve, which is dg over dt is equals to minus k lambda g, and d square v over dx square is equals to minus lambda v. So this is when we inserting this assumption into the boundary condition, and we will get GTV minus negative L minus GTVL is equals to GT V minus negative L minus VL is equals to 0. And GT dV over dx negative L minus GT dV over dx L is equals to GT dV over dx negative L minus dV over dx L is equals to 0. And we will get non-trivial solution is we do like this. And I did V negative L minus VL is equals to 0. V negative L is equals to VL, and dV over dx negative L minus dVL over dx is equals to 0. dV over dx is negative L is equals to dVL over dx. So here we will get after applying separation variable.
So I will continue 3 pieces with each lambda more than 0. The equation is Vx equal C1 cos power of lambda x plus C2 sin power of lambda x. So we will apply a boundary condition 1. C1 cos negative L power of x plus C2 sin negative L power of x equal C1 cos L power of x plus C2 sin L power of x. Negative C2 sin L power of lambda equal to C2 sin L power of lambda. Lastly, 0 equal to C2 sin L power of x. Number 2, I will apply secondary boundary condition. The equation is negative power of lambda C1 sin negative L power of lambda plus power of lambda C2 cos negative L power of lambda equal negative power of lambda C1 sin L power of lambda plus power of lambda C2 cos L power of lambda equal to power lambda C1 sin L power of lambda equal to negative lambda and negative power of lambda C1 sin L power of lambda. So it can be C power of lambda C1 sin L power of lambda equal to 0. So the last answer is lambda n equal to n pi x per L power of 2 can be n equal 1, 2, 3. Vn x equal to cos n pi x per L. Vn x equal sin n pi x per L. N equal to 1, 2, 3. So that's all my pieces. Thank you.
Good day to everyone. My name is Ramya Chandran, S64216. V in bracket x equals to C1 cos square root negative lambda x plus C2 sin square root negative lambda x. C1 cos in bracket negative L square root negative lambda plus C2 sin in bracket negative L square root negative x equals to C1 cos in bracket L square root negative lambda plus C2 sin in bracket L square root negative x. Negative C2 sin in bracket negative L square root negative lambda equals to C2 sin in bracket L square root negative lambda. We get to in bracket 2 sin in bracket L negative square root negative lambda equals to 0. The second step is negative lambda square root negative lambda is sin in bracket negative L negative square root negative lambda equals to square root negative lambda C1 sin L square root negative lambda, and then square root negative lambda C1 sin L square root negative lambda equals to 0, and we get A equals to 0. Lambda n in bracket n pi over L square. Vn in bracket x equals to cos in bracket n pi per L, and then n equals to 0, 1, 2, 3. Lambda n in bracket n pi per L square. Vn x equals to sin n pi per L, n equals to 1, 2, 3. The third step is G in bracket T equals to C negative K in bracket nx per L square T, and then un in bracket xt equals to an cos in bracket n pi x per L e negative K in bracket nx per L square T. U in bracket xt equals to an cos in bracket n pi x per L e negative K in bracket nx per L square T plus bn sin in bracket nx n pi x per L e negative K in bracket nx per L square T. U in bracket xt f in bracket x equals to an cos in bracket n pi x per L plus bn sin in bracket n pi x per L. The third step is a naught equals to 1 per 2L integrate L negative L f in bracket x dx. An 1 per L integrate L negative L f in bracket x cos in bracket n pi x per L dxn equals to 1, 2, 3. The last step is bn equals to 1 per L integrate L negative L fx sin in bracket n pi x per L dx n equals to 1, 2, 3. That's all for me. Thank you.
Lastly, I will explain for lambda equal to 0 by using the equation with x equal to c1 plus c2x. Replace it with v negative l equal to vl. Then we will get the first boundary condition, which is c1 plus c2 negative l equal to c1 plus c2l equal to 2lc2 equal to 0, c2 equal to 0. Vx equal to c1 will satisfy the second boundary condition, lambda equal to 0, Vx equal to 1. So there is no solution for Vx for lambda equal to 0.